All right, Algebra 1 folks, good morning. Happy, I want to say Monday, but I'm not sure what day you're tuning into this. I hope you're tuning in Monday. Regardless, I appreciate you being here with me. This year, we're going to go ahead and dive into a stats unit to kick off our Algebra 1 standards. You're going to see some things that look familiar, and we're going to take a deeper dive into them. So, in sixth, seventh, and eighth grade, you guys got the opportunity to see some data displays and some graphs. You guys were really tasked with building them and putting them together. And this year in ninth grade, as an Algebra 1 student, you take more of a deep dive into what can some of these data displays do for you. Okay, so follow along. After this video, if there's any kind of questions, comments, or concerns you have, feel free to maybe hop back into the video at a spot that maybe wasn't clear the first time. Maybe give it a second try in that section, and then reaching out to your teacher during any in-person learning or office hours on Wednesdays would be a fantastic idea. We're just going to kind of learn how to do that together, and I think this is a good opportunity to hop right in. So the first thing that I want to take a peek at here is, why do we even need data displays in the first place? Like, what's the point? Why do we have them? So I'm kind of answering this question right here. Well, the reason that we have data displays, one of the main reasons that we have data displays, is that it takes unorganized data and organizes it. Okay, it organizes it, and it does it in a useful way. Okay, I'm going to give you a pretty basic example, what I think is a basic example, and then just kind of to get our gears turning and whatnot, and hopefully help put some connection to this before we actually see some graph here. If you have ever been to or heard of Dave and Buster's, one thing that they do at Dave and Buster's is they study the games that are played and how many times they're played. So somebody's job at Dave & Buster's is to come in and pull the data on what machines were being played, how many times, in the machines that are played the most often, and get money for Dave & Buster's from the people playing, are games that they keep around and games that they try to duplicate and replicate and buy more of. And games that people aren't playing, they take out of Dave & Buster's and they try to replace them with new games that people are going to be interested in more and want to spend money on, so Dave & Buster's as a company can make more money. So they might have many different data displays for that, but the goal of that display would be, hey, what games are being played? Let's get more of those, or games that are similar. And what games aren't being played? Let's get those off our floor space and make room for games that we think will help make our company more money. That kind of answers this next question here. What do data displays do for us? It helps us make inferences. It helps us make decisions and possibly predict the future. Another example that I used in an extension video was, I think everybody can relate to this one, is like a fast food restaurant. One of the data that they study is what soft drinks are being purchased by customers. So if they see that lots of customers are buying Coke and buying Powerade and buying Minute Maid lemonade and buying Sprite, but hardly anybody is buying the Mountain Dew Code Red, data tells them, hey, maybe we shouldn't be buying Mountain Dew from the Mountain Dew company to put into Wendy's, and instead we're going to buy a new drink, maybe a second flavor of Powerade, or we're going to get a new flavor of Coke or Diet Coke. So they study that data and they make predictions or try to predict the future, what in the future is going to help get us more money and help our company grow. So the first data display that we're going to look at here are dot plots. Okay, I'm putting a star on each side of this. Dot plots are something you've seen before. To me, they're one of the most basic data displays, and they can tell us specific things. So after we get the chance to design this, study it, we'll kind of wrap up with, what is it that a dot plot can really do for us? Why would we want a dot plot? How would I read it? Why would I use it? And in what circumstances at best? So one of the things that I had Algebra 1 students in Mr. Neal and Mr. Shannon's class do on the first week of blended learning and over the weekend was, they had to tell me how many people lived under their roof. So how many people did they live with whether it's a house, apartment, condo, whatnot, just how many people do they live with. And I randomly chose 15 answers from the Algebra 1 group. And I am going to put them here. They're, again, 15 out of my almost 100 or so answers. And I'm going to have them right here for you. So those are, I have them right next to me, 4, 5, 7, 6, 4, 5, 3, 4, 6, 3, 3, 5, 11, 4, and 6. Those were 15 Algebra 1 students telling us how many people lived under the same roof as them. Okay, so what I'm going to do next is, in order to make this dot plot, I'm going to use this number line down below. That's this guy right here. Okay, but I can't really use a number line if there's no numbers on the number line. So I have to create that. All I'm looking for up above is what numbers do I need to include on this number line. I'm really looking for my smallest value, my largest value, and I want to make sure I cover that ground. You're probably noticing my smallest value is 3. My largest value is 11. I don't want to exclude any number in between there, so I know it needs to go from 3 to 11. Not a bad idea to have numbers just below and just above that. So I'm going to start here with 2, and I'm going to work my way all the way up to 12. Let's see if I can space it out nice. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Could have spaced it a little bit better. I think you get the point. I'm still learning how to make things look nice and neat on this new device that I have, this new tablet. So I apologize for not the cleanest of handwriting. Here we are nonetheless. Okay, so now comes time. Let's go ahead and throw these data values on there. It's called a dot plot because we put dots above each of those values when we had a response. So anytime we had a response of 3, we need to represent that there. So I'm just going to go from left to right. I think that makes the most sense. This first one is a 4. I'm going to throw a dot right there above 4. Next one's a 5. I have a dot above 5. Then I have a 7, 6, another 4. I have a 5. I have a 3. I have another 4. I have another 6. I have another 3. I have another 3. Another 5. An 11. A 4. And a 6. Okay, so we have that there. All of our values are plotted on there. We can start to make observations, right? Seeing just a big list of numbers like this, and this isn't even really a big list. It's only 15 numbers. If I really wanted to do the whole entire freshman class, I could. But that, as that list of numbers gets bigger, it's not very helpful. This dot plot is much more clear to us. We can see things. We can see trends. We can see popular answers. We can see where nobody answered. We can see the most popular answer. Lots of things can be observed. Really, these are the first 2 things I want us to try to identify. The first one is, do we have any clusters? Okay, and do we have any outliers? Okay, so those are 2 words I believe you're familiar with. I know you're familiar with outliers. I believe you're familiar with clusters, but they kind of speak for themselves. Clusters are, imagine just like a cluster of people, a bunch of things gathered in the same area or space. So when I'm looking at this dot plot, what I'm really looking at here is where does a lot of my data fall? And I think we're going to be in agreement here that a lot of my data falls in this interval from 3 to 7. And if you wanted to be a little bit more specific, 7 is it's one number away from 6. You could even say we have a cluster from 3 to 6. I think you should include 7 because it's right there next to these. Yes, it's less popular than 6 and 5 and 4 and 3. But I think that we would say our cluster is from 3 to 7. And then outliers, again, a term you're familiar with. An outlier is just kind of a data point that doesn't belong or is pretty rare or not common in the answers, kind of far away from the rest of the data. I believe we have one. I think you'd be agreeing with me. And do we have any outliers? We have one at 11, right? We have a student that has 11 people that live with them. Again, I randomly chose 15 answers. So we might have had, or we could have had some students that had larger groups living with them, above 11. But in this data set that we chose, 11 there is our outlier, right? So a good opportunity for us to write down a definition or two here of what clusters and outliers are. We just kind of discussed them. It's very easy to see them. A cluster is an area where many, I'm going to call it many or most of data points, an area where many or most data points are. Okay, so again, pretty easy to see. It pops right out to you. If I were to go ahead and put this in front of somebody and say, hey, this graph represents the amount of people that live in the same household as our freshmen at Westland, here's 15 of them, I think people would say, hey, it looks like freshmen at Westland live with between 3 and 7 people on average. And then again, outlier, we mentioned it already, but definition of an outlier loosely is a data point or points that do not seem to fit with the data. Okay, and normally they speak for themselves. In this case, this 11 data point, right, is higher than the rest of the data, but it doesn't always have to be higher, right? You could have a data point that's way lower. There's not one in this study, but it happens. It happens just as frequently as a data point being an outlier for being too high. So now it's kind of a good time to look at this and say, well, what? Whoa, where did all that just go? Let's see if we can get that back there. Going to give this a chance to load back. Come on. Are we going to get that back? Are we going to get that back? Let's find out. Nothing's coming back. What's happening here? All right, let's see. I've learned to improvise. Life is all about improvisation. I'm going to see if I can throw this back on here real quick. We had 2, we had 3, we had 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to throw these back on there. I think this was right. 2. Actually, you know what? I have the numbers next to me. I'm going to throw them back up there. We had a 4. I apologize. Thank you for your patience. 4. We had a 5. We had a 7. We had a 6. We had another 4. We had a 5. We had a 3. We had a 4 again. We had a 6 again. We had a 3. We had a 3. We had a 5. We had a 4. We had a 6. We had an 11. Okay, thank you for your patience there. One thing I will not be doing, it looks like, is zooming in and out as all of our data went away. All right, sorry, back to it. What can we learn and what did we learn? So what can we learn? Might be easier to maybe answer this right side first. What did we learn? So if I were to take all the numbers away and only put this data display in front of you and say, what can you observe about the freshman class? How many people live with them? One thing we can learn is that, again, there's a majority or a cluster from, oh, I'm sorry, we didn't have a data point of 2. I made that up. A cluster from 3 to 7, right? So hop back over to the left. What can we learn? We can identify clusters. Okay, that's one thing that we can absolutely observe. What else did we learn? Well, if I took away, or if you imagine that I just started this lesson by putting this graph in front of you, could you tell how many people were in the survey? Okay, the answer to that is yes, right? How would you tell how many people are in the survey? Well, you would just have to count the dots, right? Each dot was one person's answer. If I counted the dots, right, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? You can tell a total of 15 data points. Okay, so over here, what can we learn generally? If we're just talking about dot plots in general, we can learn the total number of data points. All right, well, what else did we learn? Well, one of the other things we said after the clusters too was We can tell that there's an outlier at 11. So what can we learn if I give you any dot plot? We can find outliers. Okay. What else can we learn? I think we can keep going. Some other words that you've heard in previous math classes. We can find a maximum of 11 and a minimum of 3. So what else can we find? We can find a max slash a min. What else can we learn? If I wanted to find the median, right, I could go ahead and cross out dots, the biggest and the smallest, eliminate the largest and the smallest answer until I get to the middle answer, right? Let's go ahead and do it. Is this going to let me switch? Let's see if I can switch here to a blue. I could cross out, I could get rid of that one and this one, 7 and another 3, 6 and a 3, 6 and a 4, a 6 and a 4, 5 and a 4, 5 and a 4. And we can easily tell that our median, see if I can get back to the red here. Let's say our median is, what is that, 5? I'm sorry. So what else can I find? I can find the median, right? Takes some work, not a lot of work. And let's see if I can make myself a little bit more space here. What else can I find? Anything else that I can find? I could do math to find the mean, right? If I wanted to find the mean, I could add up each of these. I could add 11 plus 7 plus 6 plus 6 plus 6 plus 5 plus 5, all of those values and divide by 15. I'm not going to do it here for you, but I'm going to write down, it's definitely worth noting, we can find the mean of this, which again is another word. Oh, that's a very sloppy looking mean. Another word for your average there, okay? Anything else that we can find that's important? I think those are some of the biggest things that we can notice from a dot plot. So those are things to keep in mind. I might ask you a question later, like what data display is a good idea if I want you to be able to find the total number of participants in the survey. This is a great one for it if you would just count the dots. If I could say, if I want you to easily see a cluster, this is also a great one for that. Okay, so some things to keep in mind. We're going to wrap up our dot plot there, and we're going to go ahead and move on to a second question that my freshman filled out. Okay, which is a histogram here, right? A histogram we have down below. So this new question here says, I'm going to read it here. It says, let's study how long it would take Algebra 1 students to walk from their home to Westland. So I asked my students, can you look on Google Maps and click the walk option? How long exactly would it take you to walk from your home to Westland? Not a guess, an actual fact value there. So these are the answers that I got. I'm going to write them down. Give me a second to do that. I'm going to read them from this list to my right. These are 15 other random freshmen in my Algebra 1 class. I have 9, 11, 43, 23, 41, I have 48, I have 50, I have 44, I have 45, I have 42, I have 18, a couple more, 49, I have 45, I have 8, and I have 51. Okay, so there are, again, 15 answers of how long it takes those 15 students to walk to school. Okay, there's those numbers. Those numbers don't mean much to us yet because they're just not organized, right? It's just a big list of numbers in the single digits, in the teens, in the 20s, 30s, 40s, 50s. Let's make it nice and pretty on a histogram so we can actually study it and make some observations and make some statements, maybe help us predict the future, make some inferences, things like that. So we have this statement here down below. It says, once we have this data, we need to organize it on a frequency table. On a frequency table, okay? Something you should be familiar with. This right here is the frequency table. We're going to go ahead and create this together. What a frequency table does is it's really going to organize this for us before we put it on the histogram, okay? So it's going to really let us put it in order from least to greatest and group things. So we need to make these things called intervals. which are going to be groups of numbers. A great part about histograms is these intervals, and we want to make sure that they are equal. And what I mean by that is the first interval should have the same amount of numbers as the second interval, which should have the same amount of numbers as the third interval. And what I mean by that is this category here, right? These minutes walking. Well, I'm noticing my smallest answer that I got from students was 8. And my largest answer that I got from students, I believe, is 51 minutes. So I want it to be around 8 here, and I want it to be around 51 here. But again, I want to go a little bit below and a little bit above, right? Because it's not a bad idea to include some numbers that are near it, but just kind of widen that gap for us. So I think good intervals here, you might already have them in mind. I see that I have 1, 2, 3, 4, 5, 6 spaces. So how can I get from around 8? I'm going to round down to 0. And around 51, I'm going to round up to 60. That's not proper rounding, but for this, I think it's going to work for us. And include all those numbers. So I can do 0, 10, 10, 20, 20, 30, 30, 40, 40, 50, 50, 60. This is going to work out perfect. I'm going to have my first interval be anybody that could walk to Wesleyan between 0 and 9 minutes, right? That's 10 numbers, right? If you count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That includes 10 numbers. So I need the next one to include 10 numbers without missing a number. So what number comes after 9? 10, right? That would be 10 to 19. That also includes 10 numbers. You might already see a trend here. The next one's going to start at 20 to 29. And I'm going to have anybody who it took them 30 to 39 minutes to walk to Westland. And then anybody who took them 40 to 49 minutes to walk to Westland. And anybody that took 50 to 59 minutes to walk to Westland. We always want to double check this. This is good. Nobody went above 59 in this data. So that's good. We're not going to exclude anybody. And nobody went below 0, right? Not possible for you to walk below 0 minutes to Westland. Even if you lived a foot away, it's going to take you between 0 and a minute. There can be answers below 0, but for other questions, if I'm asking you about your temperature or the money in your bank account, if you have debt, you have negative money, different things like that. But for this case, this seems like it's spread out good. Now, what we're doing next is I'm going to go ahead and switch this to a blue, is we're going to cross these out and organize them with frequency tallies over here, right? So this first data value was a 9. That falls here between 0 and 9, so I'm going to put that there. Then we have 11. I'm going to put that here in the 10 to 19 group. I have a 43, which belongs down here. I have a 23, which belongs here. 41 belongs here. 48 also belongs here. 50 goes here. 44 goes here. 45 goes here. 42 goes here. 18 goes here. 49 goes here. 45 goes here. 8 goes here. And 51 goes here. That should be a good way to check this. Is I can look and see I had 15 data values. You can count these tally marks. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Everybody's been included. Rock on. Let's go. Okay, so now comes the part where we can go ahead and get this information transferred over to our actual histogram, which is going to be right down below, which is kind of what this direction is saying. It says now we can take the data from the frequency table and organize it on our histogram. Okay, so from here again, we got to find a way to get this information right here on our x-axis down below, and we need to find a way to get this information here on our y-axis, which is here vertically going up and down. Okay, so this one has already got some little tick marks for us. So what I'm going to do is I'm going to have these groups here. I'm going to say that this first group goes from 0 to 9. This next group goes from 10 to 19. This next group goes from 20 to 29. The next group goes from 30 to 39. The next group is from 40 to 49. And the last group is from 50 to 59. Now, I'm looking up here. What's the most tally marks that we have? This guy right here, right? We have 8. So we're hoping these tick marks go up to 8. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. It's okay to go a little bit above, which we have there. So I'm going to go ahead and number those values as well. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right, now we're going to create the histogram, okay? So this is where we make those bars. It looks kind of like a bar graph, but we have our bars always touching when there's value in consecutive intervals there. So I'm looking here at this first one. Let's go ahead and choose a third color here so we're very clear in where I'm talking. This row right here, there are 2 people, I see that from my 2 tally marks, that can walk to Westland between 0 and 9 minutes. So what I want to do is I want to go ahead and make sure that I make that 0 to 9 group 2 bars tall, okay? These again are our minutes, and these again, oh, I'm sorry, that is incorrect. That is our number of people. Down below is our minutes. Okay, so let's go into the next one. This is the next one I'm looking at. Between 10 and 19 minutes, we also have 2 people. So we're going to have this next bar start at this one, and it goes all the way so it covers that group of 10 and 19. I'm going to look at the next one. There's only one person that takes between 20 and 29 minutes to walk, so that needs to be lower over here towards this one. So only one of them. There's nobody that walks between 30 and 39 minutes. So we're going to leave that one blank. We're going to get to start this next one on its own. We have this group 8 people, right, walk between 40 and 49 minutes. So I need that bar to go up to 8. Again, in an ideal world, I'm going to be drawing perfect lines here. I am not perfect. It is not an ideal world, but there we have it. In this last one, there are 2 people. That's maybe looking closer to 3. Let's act like that's a little bit lower there. That walk between 50 and 59 minutes there. Okay, so now we can almost ignore the numbers we started with. We can almost ignore that frequency table up above, and we can just make some observations and inferences based on what we have here. What is it that a histogram can do for us? Okay, well, it can tell us again. What did this one tell us? Well, look at this. What is the most popular answer that we got? It's the most popular interval of answers that we got. It's pretty clear as day, right, that there's our most popular answer right there, that really tall bar. So what can we say? We can say that most students spend, what was that bar? 40 to 49 minutes walking to school. That's if you're a walker, right? I guess we're not assuming all of these people walk, but if they were to walk 40 to 49 minutes. The next thing that we're going to do here is, so I guess what can we learn is we can find the most popular interval. Popular maybe is not the best choice of words there. The most answered interval, or the interval that has the most data responses. So what else can this tell us? Well, if I look back up above again, right, it can tell us some things like maybe where were there no answers, right? So there's a couple spaces. We can say something like no students walked between 30 and 39 minutes to Westland, and we can even make an observation on this side, right? Nobody answered above that, right? So a statement we're allowed to make is, let's get back to the writing tool here, is none of these freshmen walk more than 59 minutes, right? So it can tell you what I'm getting at there is like where do we not have data? So what can we learn generally when it's not just a study? Where is data not? Okay, where do we not have any data? Okay, another one here. If I'm looking up above, what other observations can be made there? We could definitely find what we could consider a cluster, like from our first one in our dot plot. That cluster was these answers up above here between 3 and 7 people living in the household. If we're going to call a cluster, I don't know if we can necessarily say a cluster. If we're going to say a cluster, I would say between 40 and 59 minutes here, because that has 11. No, I'm sorry, it has 10 out of our 15 answers. I think that'd be appropriate to call that a cluster. So we could say our cluster is between, what was that, between 40 and 59 when I put those two together right there. Because that's 10 of our 15 answers. So really, what can it show us? It can also show us clusters. And that are some of the main observations that we can make. Okay, so they're very good for when we have maybe some larger numbers like this. Why would we ever want one of these? I'm going to go back to my trusty blue here. Histograms are really good for when you have larger values, right? The problem we had before with the how many people live in your house, they were pretty small answers, right? We had a lot of 3, 4, 5, 6, 7, and we had 111. This is better once we start getting bigger numbers, or they're even good for when you have more responses or more data, right? If I wanted to include 80 people, doing a dot plot and putting 80 dots is not really convenient or ideal. It's been done. I've done it before. It's just, we're maybe looking for something. Can we look at some intervals in some groups like this? And they're great for finding intervals that are popular. Okay, what this can't do, this is really, really worth pointing out here. I'm going to go back to a red here, right? We know that how many people walked between 50 and 59 minutes. Well, there's 2 people, right? We know that. What I cannot say, like on a dot plot, is I cannot say the maximum / the minimum. And here's why. I can't do that. Because I don't know the exact answer in those. I know that those 2 people spent between 50 and 59 minutes walking. I don't know if those both were walkers that spent 50 minutes walking, if they both spent 51, if they both spent 52, if they both spent 53. They were somewhere in that 10-minute range, so I cannot make a claim and say the maximum was this. I can say the highest interval was this, between 50 and 59, but I cannot sit there and say something like the maximum equals 55 or 59. Just because this goes up to 59 does not mean that that person was spending 59 minutes walking to school. Where when we looked at our dot plot up here, it is very, very easy to see, hey, our maximum is right here. Our minimum is right here. These 3s are our minimum, right? Some things to definitely consider. Histograms cannot tell you, they cannot specifically tell you a maximum or a minimum. So definitely keep that in mind there. Okay, we're going to move on from histograms into our last section down below, which we have is our box plots here. Okay, a box plot, sometimes called a box and whisker plot, because they have on their display, you'll see they have boxes and whiskers. Generally, they're just called box plots now. I don't really know where the whiskers went. I still call them box and whisker plots. Maybe it's because I'm old school. The last question that I had my students helped me with was how long can they hold their breath? I had them do a timer, record themselves, and then send their response back to me, how long they could hold their breath. And here are the answers. I'm going to put them in order. I've already ordered them from least to greatest because it's going to save us some time. So here's our answers from least to greatest. We have a 10. We have 14. We have 16, 28, 29, 31, 34, 34, 36, 38. We have 45, 46, getting there, 49, 56, and 61. Is that 15? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I love it when things work out. Okay, I've put those in order because what we're going to do with the box plot, we have to first create this 5-number summary. And to me, this is generally a part that my students don't make mistakes on. It's pretty straightforward. But we have to go look at these numbers and find these 5. It's called a 5-number summary because we're finding these 5 things here. The first one is the minimum. Very straightforward. Minimum is associated with the smallest. What's the smallest number? We see the shortest somebody could hold their breath was 10 seconds, right? That of the 15 answers I used. Okay, let's hop down to the maximum, right? It's just the highest value. The highest value we have is 61, right? That's over there at the very end. That's why putting it in order was nice. The next thing that we're going to look at here is I'm going to hop to this middle one, the median. The median is that number in the very middle. So I'm going to go ahead and look at that very middle number. And to get there, I just have to do that process of elimination, cross out the highest and lowest until I have that one middle one left. If there's one middle one left, that's nice. If there's two, we have a little bit of work to do. There's me crossing out the first pair, the second pair, the third pair, the fourth pair, the fifth pair, the sixth pair, the seventh pair. Boom. Right? That's our median. So the median, if I lined those students up, the student in the very middle of holding their breath would be 34 seconds. There's half the class was higher, half the class was lower. Think about that, right? If I'm saying half the class was higher, that means 50% of the class was above the median, and that means 50% of the class was below the median, right? That's definitely something that's going to come back into play. Okay, now we have this first and third quartile left. All that is the first quartile is refinding the middle, but of the lower half. Okay, so what I'm going to do is I'm going to look at the data that's underneath that 34, okay, and I'm going to go ahead and find the median of that. Okay, so I need to find the median of the stuff just below that. I'm going to use a new color here. Let's go ahead and go with like a hot pink. Let's get some pink involved there. And I'm going to find the median of that stuff there, okay? So what I'm going to do, I'm going to cross out, I'm going to get rid of 10 and 34, 14 and 31, 16 and 29, and I'm going to star 28. It is in the very middle of my lower half. So that is I'm going to go, let's go, I guess I can go pink there, 28. Okay, so what that means is if I lined up all of my students again, and I wanted to get to the halfway point, I got to 34. And if I want the half of the lower group, I got to 28. If I'm associating percents, again, right, I'm going to use green here. This middle one, this median was like my 50% mark. And this 28 is like my 25% mark. It's like my first 25% falls underneath that, right? And I'm going to show you with the picture. Now, I'm going to go back to this beautiful hot pink here because we need to find the third quartile, which is the same thing, but it's of the data above the median. So I need to find the middle of this stuff. So let's go ahead and start crossing these. And I'm going to cross out 36 and 61, 38 and 56, 45 and 49, and I am smack dab here at 46. Okay, those are my very important numbers. And if I'm thinking percents again, right, the halfway point was 50%. Halfway of the lower 50% was 25%. What would halfway of the upper 50% be? Right? If you're thinking, it would be 70, the 75th percentile. Notice what we're counting by. That means our minimum is like almost you could think of it as like the 0th percent. And our maximum would be like almost like our 100th percent. We're just simply counting by 25% here, or increasing by 25% every time. It makes sense that our maximum is at 100% because that's all of our data. 100% of our data in this study includes the number 61 and below all the way down to 10. Okay, so now that we've made our 5-number summary, the last thing we're going to do is we're going to put this on an actual create the box and whisker plot. And to do that, again, I have this number line here, right? But there's not much that I can do if this number line's blank. So what I need to notice is what's my smallest and biggest number. I see 10 and 61. Those are kind of far apart, and I need to figure out what should I count by. Counting by ones on this number line is going to be miserable, and it's not going to be helpful. Counting by fives, maybe not a bad idea. Counting by tens, maybe not a bad idea. You just need to make sure you utilize your space wisely. So I'm going to go ahead and count by fives and hope that I do this well. See if I can go back to a blue. That seems to be showing up a little bit easier. I'm going to go ahead and do that. So I'm going to have here 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. We had a data point at 61, so I need to go one more interval of 5. Let's call it 65 there. I don't know why I wrote that backwards. Okay, now all we do is we take these 5 numbers. What colors can I use that I haven't used? Let's go ahead and go with orange. These 5 values from the 5-number summary, okay? And I need to put a dot at each of those here, right? So let's go ahead and do that. Let's go with the red for this part. My first one is at a 10. I don't have to do this in order. I just am. I have a dot there at 10 to represent my minimum. My next number is 28. I don't see 28, but I know it's a little bit below 30. So I have a dot there at 30. Whoops. My next number is 34, which is barely less than 35. I have a number at 46, barely less than 45. No, I'm sorry. Let's erase that. That's not correct. Barely more than 45. And my last spot is at 61. No, that's incorrect as well. Let me fix that. I'm sorry. There at 61. Okay. The last thing I do is I take my two quartiles, which would be the first and quartile. I box them. So I take the middle three. I create a box. I draw a line here. And then to connect these two dots to the box, I just simply draw a line from here to here, from here to here, and I have my data. Now, what can this tell me, right? Imagine now that I'm taking all of this stuff away over to the left, and I'm taking all of this stuff over here to the left, and I just was presented this box. What can it tell us? Well, some things we kind of discussed along the way. What do I see? What's the highest point? Can I tell the highest point? Yep, I can tell the max is 61, and the min is 10. There's a car alarm going off there. Glad that stopped. So what can we tell? We can tell from a box plot a maximum, and a minimum. That's convenient. Can I tell the median? Yes. Look at the median right here, right? We had the median, 34. Where's the median at here? This spot right here, right? Just right there. So I can tell that the median is at 34. It's always this space in between the box here, that middle. It's not always, you tell it's not halfway. That's just because of the data that we got back. Okay, so we can always tell the median. Okay, what else did we see? Well, think about just that 5-number summary. We could tell the first, I'm going to put first Q for first quartile was at 28. We see that just from looking right here. And I see that the third quartile is at 46. I can see that from looking there. It's hard to tell if I'm just looking if it's at like 46 or 47, but we can generally tell where it is. So what else can we tell? We can tell the first and third quartile, right? Some very, very useful things. And then I'm going to put this pretty sizable here. I can tell percentages. If I want to tell, or if I'm ever asked, what percent of the class was this? This is perfect. A box plot is great. If I asked you, what is the highest 25% of our class able to hold their breath for, that's this chunk right here. The highest 25%. This piece is 25% of our data. This piece is 25% of our data. This piece, it's getting a little crowded. Let me clear a little bit of space here. Let's go back here. This piece is 25% of our data. And this piece is 25% of our data. Now, you have to think outside the box a little bit. A little Taco Bell slogan there for you. But those pieces don't all look like they're the same size, and that is okay. That's actually great, and it's very, very common. It's very rare that they would ever all be the same size to our eyes. We have different data points kind of dispersed throughout this data. If I add all these up, 25 plus 25 plus 25 plus 25, that's 100% of our data. That means everybody in the survey was included, and I'm looking at each and every one of them, right? So these are different sizes. There's just a lot of answers packed in this space. What does this space right here cover, right? This 25% covers the number 28 to 34. Look up above. Look at how many values are there. 28 to 34 goes from 28 to 34. We have a lot of answers in that space, right? We have 1, 2, 3, 4, 5. We have 5 of our answers, right, packed in that space right there. So we have a lot of data falling in that space right there, okay? So things to keep in mind. Again, if you imagine, this is kind of an outside the box thinking as well. If you take a cookie and you break it in half, a lot of times, even though your goal is to break it in half, you're not going to get exactly half on both sides. Then imagine that you take that half, right? Here's my drawing of a cookie. This is beautiful. I take that cookie and I cut it in half, and then I cut those halves in half. Each one of those is 25%, right? There's a great chance that they're not actually going to be exactly the same size, okay? But you need to consider that even though we have 25% of the data in each of these four pieces, they're not going to be the same size to our eyes, but really 25% of the data is packed into those pieces. Okay, some things to consider. What else can this do for us? It can tell us the range. Whoops, should be writing there. Which the range is always the highest minus the lowest, which would be 61 minus 10. So our range of this is 51. The difference from our highest to lowest student is a 51-second breath holding difference. So it can always tell us the range. What can't it do for us? One thing that it cannot do is it cannot tell us a total number of data. It can't do that because I just am looking at basically percentages and gaps, minimum, first quartile, median, third quartile, and maximum. I can't go up here and count this like I could go up above and count these dots up here, right? I can tell there's 15 people there because I can count 15 dots, right? I can count 15 participants here because I could add up. Well, there's 8 answers there. 8 plus 2 plus 1 plus 2 plus 2. I can count those, right? I cannot count that from this. I am just simply looking at this box plot and finding some of these other pieces of information. Again, a big one, I can't emphasize this enough, I guess we'll hit it with the blue, is percentages. If I want to know percentages, or even something like an IQR, your interquartile range, right? Your IQR, right? That would be your third quartile minus your first quartile. So 46 minus 28 would be 18, right? So you can always tell the IQR, something we'll look at a little bit in the next set of notes as well. Some of the many things that you can observe from there. So each of these three have their advantages. They tell us different things. They show us different things. Some of these three data displays between dot plots, histograms, and box plots show us similar or the same feature, but some of them show us something that another one cannot, okay? That's about it for now. I have a follow-up Edge Elastic 10-question practice that really lets you look at this, and I have an optional video as well with some more examples. So take your time to look at those and answer the questions, and anything that's not clear, hop back into this video and see what it is that this video can do for you or your teachers can do for you, and we will go ahead and do our jobs in answering those. Thanks for following along with me today on data displays and their advantages and disadvantages, and we will talk soon.